everybody. My name is Logan Huskins, and I guess just a little bit about me before we get started. I am a software developer. I work at Love's Travel Stops. I've been writing Node at work pretty much exclusively for the last nearly 3 years. Married, my wife showed up. That's pretty exciting. I'm glad she gets to see me talk. I also help run an Oklahoma City mechanical keyboard user group. So if you're interested in mechanical keyboards, hit me up, and I can show you where all that stuff's at. It's pretty dorky, but I have fun with it. So my plan with this talk is basically I'm going to give some really high-level concepts on some stuff, and if it is complete and utter nonsense, as most of it will be initially, I will circle back to pretty much every bullet point I have and kind of explain more in depth what those things are. But if you have questions before that, or if you have questions after that, just kind of wave at me, get my attention. I'm be happy to answer as many questions as I can. So let's start off with what Node.js is. And this is pretty much right off the bat going to sound like nonsense, and like I said, I'll circle back on everything. Node.js is a JavaScript runtime built on top of Chrome's V8 engine. It is scalable, event-driven, has fast asynchronous I/O, which is input-output. It's generally used to make web servers and developer tools. So first thing right off the bat is talking about V8. If you haven't written Node before, you've probably not really heard much about V8. V8 is the JavaScript engine inside of Chrome that is used to execute the JavaScript you have on your website. So if you ever have built a website with JavaScript, whether you're using just plain JavaScript, using Angular, React.js, anything like that, when you run that application inside of a web browser, the part that actually executes the JavaScript is V8 if you're using Chrome. The cool thing about V8 is it's not actually tied to Chrome itself. It can be embedded into any C++ application. It's cross-platform, so it runs on basically any operating system that you would expect a user to have, Windows, Mac OS, Linux distributions, BSD, stuff like that. The C++ application that it is used in that we're talking about is Node. So it is basically V8 outside of the browser and embedded into a separate runtime for JavaScript. On top of that, Node provides a lot of libraries that aren't initially available in V8, and we'll run through a couple of those. So I'm going to go through some quick examples to show exactly what that means. Up until this point, what questions do you guys have? Anything? All right. First example, we're just going to do a simple hello world application. If you guys have ever programmed anything, I'm sure you've seen this before. But this is just, who all in here doesn't have experience with JavaScript before I get started in this? It doesn't have to be a lot of experience, just like any experience. Okay, good. So I won't explain what console log is. But we're going to go ahead and just run this. And right there, it's printed out hello world. So how we ran this application is we just called the node executable and told it what script we wanted to run. And then it'll run through that script, and without a browser, it will execute all of the JavaScript in it. And I know this isn't a super exciting example, but it goes to show just the ability to run JavaScript without a web browser. So we'll go to a little bit more in-depth example that shows some stuff that you couldn't necessarily do in Chrome. And I'll go ahead and run through what this code does before I run it. The first thing it does is it prints hello world for you guys again. Then it accesses a global variable that's a part of Node called process, which is something that's Node specific and you don't really do in the browser. And it stores a lot of metadata about what application you're running and a lot of global things. You can attach global things to it. So if you have variables that you set outside of the application or something like that. And we're accessing the arguments on it. So basically, I'm going to call this application and pass it arguments, and then it's going to iterate through all of those arguments and print out what the values of them all are. And then it'll print we're done when we're done. So what it's done is it's iterated through all those arguments. It actually took the executable of Node as the first one. It took the script that we gave it as the second one, and then all the things that I passed it from there on. This shows that we can basically use things from our operating system that don't have to do with our browser. So I can pass it anything I want to. A lot of people will use this to do environment variables. So if you have things like secrets that you don't want to actually store in your code, passwords to services, database keys, stuff like that, they'll get passed in sort of a similar fashion depending on how you set up your application. What questions do you guys have about those before I go back to the slides?
How do you know how many arguments for each is going to have?
So you can pass a third argument to for each, or it returns a third argument that is the actual array itself, and if you wanted to, you could check the length of that array. But what for each does is it iterates over the array and it stops at the last element of it, so you won't go over however many there are. So it takes all of those arguments as an array and goes through each single one of those and performs this bit on each single one of those. So you're not going to go out of the bounds of that array or anything because of that. Does that kind of answer what you're looking for? Okay. You can write developer tools with Node.js, and there are lots of those. We'll cover probably the biggest one in a little bit called NPM. But beyond those, Node is primarily used to write web servers. Web servers, for those of you that aren't familiar, are basically how content is stored and served on the internet. It's where users' data, tweets, posts, and all their information are stored. So kind of an example of this is when say you're on Twitter and you tweet something. When you hit tweet, it doesn't just stay on your computer. It has to go somewhere. That way when other people who are using Twitter and are following you on Twitter want to see your tweets, they can get them from somewhere. So you hit tweet, it sends it up to a web server, in this case, Twitter's web servers, and the information is stored there for anybody later to come back and request. So we're going to kind of cover what something called the client-server model is. So I want to run through a couple examples of that too. Web servers communicate with databases, with file systems. They communicate with other web servers. So if you've ever heard of like SQL Server or MySQL or anything like that, they're not running on your computer when you're running web applications. They're running on a web server somewhere. For instance, say you have a tweet that has a picture in it. I don't know how exactly Twitter handles their images, but how you could handle it is you could save it locally onto that web server, which means that like anybody who makes a request to that web server will then access the file system on that web server and send that image down. So it has a centralized place for all of your tweets, all the images you send up. Basically, any information that is stored on Twitter is on their web server. Web servers also communicate to other web servers through networking protocols like HTTP, which is mostly what we'll discuss today. An example of that would be you send a tweet that has a link to a free code camp blog post. And when you see that tweet on Twitter, you'll usually see like a little image that has to do with it, the link, a couple sentences about the link. What happens is you send that tweet, it goes from your browser to a web server, to Twitter's web servers. Then Twitter's web servers see there's a link in it, and then they make a network request to free code camp's web servers. So none of that happens on your computer. It all happens on their server. Web servers can be written in Node. They can be written in Java, Ruby, C#, and a host of other languages. Obviously today we're going to be focusing on Node. What I just described to you guys, though, has a specific name. It's called the client-server model, and it's a way to split responsibility between your web server and the user's browser, where the web server handles databases, inter-client communication, and authentication. The client handles view logic, requests info from other servers, stores data in a database. For instance, with something like Facebook, if you were on Facebook Messenger, you'd send a message to somebody on Facebook. It wouldn't go directly to their phone. It will go to Facebook servers, and then their phone would request that, or it would push it down to their phone, depending on how they set that up. Does anybody have any questions about web servers or kind of what the client-server model is? I can show you, after this I'm going to show you some code of like what a web server looks like. No questions? All right. Before we get into that, actually, I'm going to talk about why you would and wouldn't use Node.js. And once again, this is going to be nonsense until I kind of break it down and explain it step by step. But Node.js is good for asynchronous applications that require non-blocking input-output and are event-driven. Doesn't mean much. I'll show you examples. Node.js is not good for CPU-intensive tasks, so anything that requires a lot of math, machine learning, AI, stuff like that. Node isn't very good at that because it doesn't have a way to handle it in a non-blocking way. And it's also good for non-server applications. It's also not good for non-server applications like game engines, mobile applications, stuff like that. So, like I mentioned earlier, when I mentioned non-blocking events and asynchronous I/O, what that means is, so say you had a web server that read a file from the file system and sent it back down to a client's browser who was requesting it that. Say it was an image. Sometimes reading files from a file server takes time. So you could have a very slow disk, and it could take a couple seconds. So person A, with their web browser, makes the request for that image. Person B, with another web browser, then makes a request to the same web server, but they request something that's a lot quicker. For instance, they want to get the information about a user. They want to look at their profile on Twitter. And for some reason, that takes longer than reading that image from the disk does for person A. So person A makes the request, and because the input-output in Node is non-blocking, it basically pushes that off to the background by itself and continues that disk read, while person B can freely make a request for that user information, pull it back down, and it gets pushed back down to their computer just fine. Then when person A, when the image is done loading from the disk, it gets sent back down to person A. What would happen in something that was not non-blocking or was blocking is when person A made the request for that image, the server would stop everything until that image was read in from the disk, and person B would be stuck waiting to see their profile information, even though that's a lot quicker than what person A is trying to do. So they'd have to wait for person A to get done before they could do anything. And that isn't good because these things are running on your servers and their clients on completely separate computers in completely different parts of the world. You don't want them to have to think, oh, this is going slow because person over here is doing something else. Like that's not gonna fly with them really. Do we have any questions about non-blocking I/O or when you would or wouldn't want to use Node? Was an example of something that would be synchronous? Okay, the question was, what's an example of something that would be synchronous versus what I just mentioned, that's something that was asynchronous? So reading that image from your disk on your computer could be synchronous, but Node does it in an asynchronous way. So what I mean by that is when you make that request for that image, like I said, Node pushes it off into the background and continues doing other things. If it was synchronous, and you can in Node, you can actually read image, you can read stuff from the file system in a synchronous way, but it's like default asynchronous. If it was synchronous, it would stop everything else down the chain from happening, so all other users. So the things that are asynchronous could also be synchronous. It just depends on what you want it to do, and with Node, the synchronous stuff is kind of the default. So anything that is asynchronous could also be synchronous. What other questions do we have? All right, I have more code examples. These are actual web servers this time. So the first one is going to listen for, I'm going to show you two applications. They're both pretty similar. The second one's just a little more in depth. The first one just listens for an event on the server. The second one listens for specific types of events and does specific things for those. All right, so I will run through this code first. The first line of this code is requiring in the HTTP module. Bits of code in Node that are provided by something other than the script you're in are called modules. So you can write a module and store it in your application. Node provides a set of built-in modules, HTTP being one of them. There are third-party modules that you can install through tools that we'll discuss later called NPM. But this is how you require them. And it basically gives you access to everything that's in and exported from this HTTP module in the variable that I call HTTP. So the first thing we'll do is create a new server. HTTP has a function on it called create server. And you give that function a callback. And what that means is anytime anybody makes requests to this server, this highlighted code will execute. And I'll show you in a second what this highlighted code actually does. We assign that server to the variable server because we do stuff with it down here. Here we are creating a port. And I'm going to be running this locally with nothing else on my computer. So the example, so ports won't, you have to define a port, but a port doesn't matter that much in this situation. But what a port is it's basically a way to tell specifically what you're talking to on a computer. So there's a bunch of networking ports open on my computer right now for different reasons. Say I had 5 node applications running on my computer. They can't all run on the same port. So one would run on 8000, one would run on 8001, 8002, and so on. And you make requests to that specific port. That way when you make a request, you know what you're talking to, and the node applications know which of your services needs to respond. So the server variable I defined up here when I created that server, I'm calling the .listen function on it. And what that tells you is it tells the server to begin listening for network requests against it. I pass it the port, and then I pass it a callback. So this code is executed when the server begins listening. So the first thing that should run when I run this is this console log right here, saying the server started to listen on port, and then the port number. So let's go ahead and run it. We're going to run it the same way, node, and then the name of the file, which is eventserver.js. Sure. And there we go. The first thing it did is says server started on port 8000, and then nothing. The application didn't finish. It's still just sitting there open. Well, what's going on? What it's doing is it's waiting for me to make network requests to the server. And when I do make network requests, this bit of code is going to be executed. So let's go ahead and make a network request. To do this, I'm going to use a tool called Postman. And can everybody kind of see that? Light theme? Okay. Is that better? I haven't seen a way to zoom in Postman. I will very explicitly talk about what everything is happening in it. So I'm going to type localhost. Localhost is my computer. So this is where you would type the website you're talking to, like google.com or whatever. And just localhost is my machine. And then the port, so I know what application to talk to. I'm making a GET request, which is an HTTP method. We'll talk a little bit about HTTP as we go through these examples. GET is one of the requests you can make through HTTP, which is a networking protocol. There's a bunch of other ones. You don't use most of them most of the time. You use a couple of them. And I'm going to go ahead and send that request. The response is a JSON object, which if you're familiar with JavaScript, you're probably familiar with JSON, but does anybody not know what JSON is and would like me to go into that? Awesome. So what JSON is a way to basically collect and organize data. So say you have a bunch of information that you want to send around between applications or send to a user. You would send it, and JSON is a good form to send that in. JSON has a series of keys and values, and the values can be more JSON. So the key in this instance is message, and the value is hello world. You can have as many keys and values as you want. So if you were making a request for like your profile on Twitter, it would have your username, and then the value would be your username. And then it would have your profile picture, and the value would be where you get your profile picture from, and stuff like that. The status, I'll go into the status in a second. I'll show you the code first. So what happened? When we made the request to this server, like I said, this code is what's being executed. Anytime a request is made in a node application, you're going to have access to 2 variables, request and response. The request is the data that the client sends you, and the response is the data you're sending back to the client. The first line of code, we're taking this response and calling a function called writeHead. And what that does is it writes essentially metadata to the content that you're sending back to the client. I'm sending back a 200, which is an HTTP status code. 200 is the universal way in HTTP to say, that went great. Everything did exactly what it was supposed to do. Here's your information. And I'm writing a content type of application JSON. And all this is doing is it's telling Postman or the browser or the user's mobile phone or whoever's making this request that this is the type of data I'm sending back. I'm sending back JSON. Then I'm writing the actual data I'm sending back to the response by calling response.write. I'm sending back that message, hello world, back down to Postman. And then I'm calling response.end, which sends the response back down to the client. So we'll go back to Postman, and I'll show you where all of these things are showing up at. So this is the data that got sent back that I explained earlier, the message hello world. This is that application JSON that I showed you being sent back. The rest of it is stuff that Node is adding itself. And here's where it shows the 200 OK. There's lots of HTTP status codes. You've probably seen 404 before. It means a resource isn't found. You may have seen 500. It means their server threw up, basically. It means something happened on their end, and you just need to keep going about your business. What questions do you guys have about this little web server? Anything specific? All right. So I'm going to show you the more in-depth example now. So that server, what it did was it listened for any request and it responded to it the exact same way. This one will handle different requests a little bit differently. So here's the main file in the application. It probably looks pretty familiar, except I require in an additional file. So the first thing I require in is HTTP, which is Node's HTTP module that we've discussed a little bit. The second thing I require in is a file called a router. Router is a file that is actually inside my application. So it's something that I've written, made a module, and then I'm exporting to be imported elsewhere. That router file could be used in thousands of other files, but we're only really going to be using it for this one. Same thing here. I'm calling http.createServer. It's doing something a little bit different on the request, but I'll go into that in a second. Port 8000, same deal. And I'm calling server.listen, and I'm saying the server started and is listening on port 8000. So let's go ahead and start it up. Starting it the same way. Node and then the file name. Server started on port 8000. So what is this doing different? This, on a request, is calling my router function and giving it a variable that is on the request that the user sends in. So I spoke a little bit earlier about this get up here. There's also post, put, delete. It's taking this and it's performing a different action based on what kind of HTTP request is being made. And then I'm passing that function that's being called the request and the response so it can perform operations on it. Over to my router file, the only two things that I'm actually going to perform anything on, just for sake of brevity, is a GET request and a POST request. So to explain the difference a little bit, a GET request is a client, being phone, web browser, mobile app, saying, can I get this information? A POST request is a little bit different. A POST request is you as a client saying, go ahead and create this information on the server. So back to the Twitter example, when you tweet something and you click tweet or you click send, it posts it to the server and it says, hey, here's a tweet, save this stuff. Or when a new user is created in your application, you're saying, hey, here's a new user, save this stuff. And that's what a POST request is. So let's go ahead and do the GET request. I'm going to do it a little bit different this time just to show some different examples. I'm going to add something to it called a query parameter. So at the end of the URL, I'm going to add some data. I'm going to add name. I'm going to say name is Logan, because that's my name. This could be any information, but it's there basically to narrow down the stuff you get back. We're not going into all of that logic right now. I just kind of want to show you an example of there being more information in a URL and the server handling that information and responding to that information in a specific way. So I'm going to go ahead and send it. And here we've got a JSON response back in the same way. It says message, thank you for getting. It's a different message than it was last time because it's a different server doing different logic. And it returns the query arguments I sent, name equals Logan. Normally, you wouldn't just have a server that sent back the data that the client sent up to it. That doesn't make a lot of sense. I just kind of want to show how the plumbing of Node works and how a web server has access to this information and what use it all is. And once again, status is 200. What questions do you guys have up until this point? All right. Don't hesitate to ask questions, guys. I like questions. Questions are good. Because if you're not asking questions, it makes me think I said everything perfect and explained everything perfect, and I know that's not true. All right, so here's the GET request. Because we're over here, router.method, method is going to be GET, so it's going to execute this code. It's being passed the request and response. The only thing we're doing a little bit differently here is we're trying to discover what those query values are. We're using a module called URL, which is a built-in module of the node that's being required up here. Oh, something happened. Cool. Using a laptop mouse. Stuff gets dragged around sometimes. So URL has a method on it called parse. You pass parse the URL you want to parse. And what parse does is it breaks apart the URL into usable chunks of information, so you don't have to take that big long string of data and take it and find the information you want on it. This will give it to you in a way that's a lot easier to consume and a lot easier to handle. Request has a method on it, or has a property on it called URL. Remember that request is what the client is sending you, the web server. So it takes this URL, parses it, and then there's a parameter on it called query, being those query arguments, and I'm getting that parameter off and assigning it to query. And this is going to be a little bit more of the same. Response.writeHead, I'm writing a 200 saying everything was successful, and that JSON is the type of data I'm sending back to the client. And then I'm writing the message, which I'm saying thanks for getting, and then I'm putting that query back in that thing that I'm sending back down to the client. And calling end, which sends it back down.
So your module that exports is a dictionary of functions.
I'm sorry, what was that?
This module that exports, is it sort of like a dictionary of functions?
The question is the module that I'm exporting right here a dictionary of functions? And that's exactly what it is. It's basically a dictionary, or if you use other languages, they're called associated arrays. Dictionaries are usually what they're called in Python and a couple other languages. And because JavaScript has what's called first-class functions, the values in these dictionaries are functions. So when you access things in a dictionary, you can pass it stuff and then perform the logic on it. Does that answer your question? Awesome. I guess let's cut back a little bit. Like I said, this is a module. Module.exports is how you export the code as a module to be consumed by other stuff. So if I wanted information to not be available to anybody else, but I wanted some of it to be available, I could do code here, and it's not being exported. It's one of the few ways that JavaScript offers encapsulation, if anybody knows what that is. So now we are going to talk about the post request, which is a little bit more complicated. Luckily, you probably won't ever actually do this. There's a lot of node libraries that abstract this for you, so you don't have to get down and dirty reading this data in like this. But I'm going to kind of show you what it looks like, and if you don't understand how some of the data is being read in, it's not a huge deal. Like I said, you're not going to do this right off the bat. So I'm going to go ahead and make that post. I've actually got it right here, so I don't have to type it all out. So I've got it set to post here, which means the client's saying, hey, server, go ahead and create this data and save it however you need to save it. I'm telling the server right here in a header that the content type is going to be basically a form. This is the content type you'll usually use if you're filling out a form on a website. Remember, this content type header is the same thing that the server used to tell the client that they're sending back down JSON. So you're telling it you're sending up this form, and it will probably send back down JSON. This isn't going to send down JSON, but the other examples did. And then I'm sending it a body. And what that body is the data that I wanted to create. So I gave it a name, and I gave it an address. The server could require any combination of information in this body, but this is just for the example what we're sending. Name being Logan, and address being 123 Node Lane. Any questions about this post I'm about to make to the server? All right. It is not in JSON. You can send data up in JSON. How I don't do a ton of front-end work. How I think the form URL encoded content type works is I think it's going to append it to the URL. But you could send it up as JSON. You could send it up as XML. You could send it up as a bunch of different stuff. And I'm sorry if that information was wrong. So we've got the post right here. So how this data is going to come in is it's going to come in chunks, basically. So as the client is making the HTTP request to your server, it's coming in not as one big chunk of data over the network. That would not make a lot of sense because it could be a huge request. It's coming in little tiny bits. So it's coming in part A, part B, part C, and then we'll let my server know in the last chunk of data that it's the last one. So I am creating an array called body, and this is where I'm going to be putting the data that's being sent up to the server. Here's where I'm registering events on the request object. What this is saying is anytime this event happens on this request, anytime this thing happens, execute the code that's given. So the first one is data. The data event is when one of those chunks arrives from the client to the server. So this will happen, could be hundreds of times depending on how big the request is. And this is end. This is saying execute this code when the last chunk of data has arrived to the server. So all we're doing when these chunks come in is we are pushing them into the body array. Now this data in the body array isn't exactly usable for us yet because of the way the HTTP request comes in, but we will clean this data up and make it usable for our purposes. So here's where things get a little bit hairy, and if you don't get all of this, it's not a huge deal because you probably won't actually do this. This is just, I want to show that Node is kind of JavaScript's a higher level language, but Node provides some lower level, doesn't provide as high level abstractions as you might be used to. There is stuff built on top of Node that provides those abstractions, but Node has some kind of lower level stuff in it. So here's query string. I required it up here. It's another module Node provides. And I'm telling it to parse this data. So what that array is from the data that's coming from the client is called a buffer, which is a type of data, or a type of data type, basically. So basically what I'm telling the buffer to do is take that big array, concatenate it into one long buffer, and then change it to a string. There's lots of good information on Node's documentation about what a buffer is and how buffers work with HTTP requests. It's kind of outside the scope of this, but if you want to get into that, it's pretty interesting. So that's going to be the kind of data that query string can parse when it's all a string. So it takes that big buffer, makes it one long buffer, and makes that buffer into a string. And then the query string library parses it. And then I assign that to a variable called parsed post data. All right, down here, because generally when you post stuff to a server, it's going to get saved in a database of some sort. I made a little file called repository. It doesn't actually do much because I don't need to set up a database to make this example, but we're going to pretend that the save function here saves the data. But right now all it does is say that it's been saved to a database. In the real world, this module there could be errors. For instance, if you're saving something to a database and you can't make a connection to that database for some reason, or the database is down, or there's something wrong with the data. This could throw what's called an error. This won't actually throw an error because I don't have it set up to, but we're going to pretend it could, which is one of the good things about modules. Modules in this situation allow you to not know what's going on inside of a module, but still call the stuff in the module. So I don't know that this isn't throwing an error. I just know that it should be saving the data. So if there was an error, I need to wrap it in what's called a try-catch block. Try means execute all of the code in the try, and if the code in the try has an error, stop executing it and perform what's in the catch. This code will never get accessed, but if it did, here's how it would work basically. I create a variable called response code. I want to send back a 201 down to the client if the save is successful. What a 201 is, like a 200, it's basically saying everything is okay, but in the context of creating data. It basically just means data's been created. Or if there's an error, I want to log it out, and I want to say 500, there's been a server error. So it calls repository.save and passes it the data because that thing doesn't actually do anything. It succeeds, and I set the response code to 200. It writes the response code to the response, and then it ends the request, which means it sends it back down to the client. So let's go ahead and do this. And here we go. Response code is 201 created, and I don't send any data back because there's no reason to. really. With a post, you're just creating the data. You don't need the data back. You've already got the data. All you need to know is if it was successful or if it wasn't. And down here, we said we save this data to the database. All right, what questions do you guys have about these? No questions? All right, so let's talk a little bit about NPM. Once again, this is going to be one of those situations where I say a bunch of nonsense and then I circle back to what each of them mean when I'm done. NPM is a package manager and a registry for Node. NPM is also a CLI tool to manage the packages on your machine, which is that package manager. It allows users and enterprises to share and use over 600,000 packages. So there's a lot of code on NPM that's not yours. You have access to a lot of it. Not all of it's great. A lot of it's very, 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 very good, though, and pretty much indispensable to the Node ecosystem. So let's talk about what a package manager and a registry are. A package manager is a way of managing code your project depends on. It makes it easy to incorporate new code into a project and helps maintain consistency between installations of your project. So say you have a dependency on a library that somebody else wrote. A package manager makes it easy to incorporate that library and bring that library into your project. It creates a way for other people who are using the project to know what libraries your code is using. So that way, when you're developing something and then your friend takes over and starts developing it, or your coworker takes over and starts developing it, they have a way to reinstall all those packages that you are using. When your code is done and you're ready to deploy it, the server knows where to get all those packages from, and all of that is because of NPM. A package registry makes it trivial to share the code you've written and easy to access code others have shared. So the package manager lets you handle those packages on your computer, download them, install them, and everything. A package registry is a place where you can upload code for other people to use. So you use the manager to access the registry, basically. Does anybody have any questions about NPM? I'm going to go into some examples of how this all works and set up a project using NPM in just a moment. All right. So we're going to create a new directory here and call it test npm. I did not create it in the right place. So how you create a new project and say this is a project that's going to use npm, either to be uploaded to npm's website later for other people to use, or for you to download other people's packages to use on your application. You type in npm init. And this is an example of a developer tool that was written in Node. So it's going to ask me a couple questions for how I want to set up the code, how I want to set up the project, and then I'll show you where these settings are stored. It's going to ask me the package name. I'm going to leave it default and just call it test npm. Version 1.0. Description, a little test npm thing. The entry point is the main application, the main file in your application. I'm going to create an index.js for this. A test command, this is if you have automated software tests. We won't for this example. A Git repository, there's none for this, but if there was, you put the GitHub URL here, if you're familiar with GitHub. Keywords, this is where you could type, if this was like a library that handled managing dates or something, managing like date time strings, you would put dates here. But this isn't going to do anything, so we aren't going to put anything here either. Author, Logan Huskins. License is going to be MIT because I don't care what anybody does with it. And all of that's okay. So what this did was it created a file called package.json. This basically has all of the settings that I just specified. Name, version, description, the main file, scripts, which we will go into in depth, author, and then the license. We actually don't have a test script for this, so we're going to make another common script you'll see, which is start. And I'm going to call node index.js. Remember earlier how whenever I ran the project, I was typing in node and the name of the file? Now I'll be able to type in npm start, and it will do that for me. So let's do a new file. Call it index.js. and I'll show you why that's useful. So we're going to go ahead and run npm start, and it ran hello, just as we'd expect by writing hello in a console. So why this is useful is I want to take that longer example with all the command line arguments and copy it into this file. And remember how before I had to type in node and then the name of the file, and then I typed hello, and then my name, and then free code camp? I can do all of that in my scripts. So now when I run it, it executes all of them just like we had before, but I don't have to type in everything every single time I do. This is useful because this part, when you have a big production application, can get really complicated. You can have scripts that run before your application starts up. You can make sure your database is in a good state. You can have lots of variables that your application needs that are provided from here. You can do lots of stuff. You can also have scripts that generate documentation for your application, scripts that run database migrations, anything of that nature. So now I'm going to show an example of us installing a package through npm. Then we'll wrap it up and I'll take questions. So to install a package from npm, you can, actually let me show you npm's website where all the packages are. So this is npm's website. And there are 600,000 packages, give or take, on here. A popular example is a package called Lodash. Lodash provides a lot of little utilities for you to use in your code. It's kind of a generic set of functions that do stuff that you don't want to have to implement yourself because they can be kind of complicated and miserable. So we're going to install Lodash in our application. How we're going to do that is they have an example of it right here. For instance, if you want to see how popular this stuff is, how many people use it, Lodash has been downloaded almost 15 million times this week. That's a lot. That's just this week. I'm probably responsible for 5,000 or 6,000 of those. We run a lot of continuous integration. That might not have been an exaggeration. It might actually be a couple thousand. So we're going to install npm install --save Lodash. Make sure you spell what you're installing right, because there's stuff on npm that looks like other stuff. So make sure you're actually looking at what you're installing when you install it, so you don't install somebody else's code that acts like Lodash but isn't actually Lodash. So we'll install it. It's going to contact npm's registry to get that data. And look, we now have a dependency list. And it tells us Lodash and what version of Lodash we're using. So now, in our application, I'm not going to show you how to use Lodash or what Lodash is, but it's just a popular example. So here we've required it in, like we had everything else that we had from the Node standard library stuff, the stuff that I've written myself. A lot of people will name the variable Lodash an underscore. You could name this anything. You could name this Lodash or whatever else you wanted to, but most people just call it underscore. So if you ever see anybody using underscore dot something in JavaScript, they're either using Lodash or underscore probably to do stuff. And there's, like I said, there's tons of other packages on npm that abstract away a lot of the nasty stuff that I was doing in that post request. And one popular one is called Express. I use Express every single day. It's got about 5 million downloads on npm this week. Express makes it super easy to do those gets and those posts without having to get down and dirty with that data. All right, what questions do you guys have about npm? Mm-hmm.
So you made a keyword named start.
Yes.
Do you have another keyword under that?
Yes, so what the question was in my package JSON, I have a script called start. Can I have more scripts here? Yes, you can have tons of scripts here. For instance, you could have a script called doc, and what that does is generates docs, your documentation for your API. It's not actually going to do that because generate doc doesn't do anything, but you could, and for that you would type in npm doc, and it would pretend it does something. It would generate your documentation for you. You can do, probably the most popular one you'll see other than this is test. And if you had automated software tests, you would type in npm test, and it would do all the things to orchestrate those software tests for you. So you can put as many scripts there as you want. These scripts can be, so this This stuff can be other files. So you can have a file, you can have a directory in your project called scripts that does a bunch of really complicated stuff and just call it with npm test or whatever. And that's pretty much what npm test does.
Can you run multiple scripts at once?
Can I run multiple scripts at once? Yeah, there's, I'll just do the same thing twice. I'll run it once with all the arguments and once without. The way I would do this though, is I would make a script called start and test, and do npm start npm test, and it would run both of them for you. Or you could do that from your command line. But if it was something that you did frequently, you could make a script for it, which is the good thing about npm, is anything you do a lot, you can do through an npm script. All right, are there any other questions? One more question, come on guys. Got a question? Am I responsible for any of the downloads of it? He asked if I am responsible for any of the downloads of the Express thing. Yes, for every download of Lodash, I probably also downloaded Express the same amount of times. Because all of the projects we run in production at Loves use both Lodash and Express. So anytime we publish those, which could be 100 times a day, those get downloaded. So we do it all the time. And having NPM do that automated for us is great. I'm not responsible. He asked if I was responsible for all of those weekly things. I'm not responsible for all of them, but I'm responsible for a non-trivial amount of them. All right. Are there any other questions before we wrap up?
Do you have any resources for learning more about using Node or NPM?
Good question. The question was, do I have any resources for how to learn more about Node or NPM? This is Node's website. They have, on their documentation page, they have guides, and there's lots of interesting guides in Node. A lot of them aren't super beginner focused, but if you have a little bit of programming background, they're a great place to look at. It explains some more advanced concepts in Node, like the event loop and how buffers work and how blocking and non-blocking input-output work. Free Code Camp is a great resource. I'm sure they have tons of Node stuff on there. I've seen some of it, and I've used some of it personally, and it's been pretty solid. And then there's tons of just like people posting stuff on Medium that are like Node articles. And not all of them are great quality, but they're at least a good place to start. Any other questions? Mm-hmm. Yep, there are supposed to be two. He asked if there are supposed to be two ands in that NPM script, and the answer is yes.
Is there any cheat sheet for all the HTTP codes?
Yes, for all the HTTP codes specifically? Yeah, there actually are. So, the question was, are there any like cheat sheets for the HTTP status codes that I was discussing earlier? And there are. MDN is Mozilla Developer Network. Mozilla makes Firefox. They have great documentation for pretty much anything internet or JavaScript related. They have every single response code here. You won't use most of these. You will use a lot of them. Node also has documentation for their APIs. It's kind of hard to get to. You go to docs, and then you go to docs again, and then you click the first link. But here's all of Node's documentation for all of their libraries. For instance, we use the HTTP library. Here's all the stuff in that HTTP library. It's kind of hard to read if you're not used to it. I wouldn't recommend just like sitting down and reading this unless you like have been developing stuff for a while. But it's there if you want it. Any other questions before I wrap up? All right. Thanks, everybody.